Okay, so let's just write a couple facts down that we need to remember. Energy is the ability to do work. Thank you. Okay. So make sure you write that down because it's like the first question on your assignment. So then there's a couple of things I want to remind you guys. Well, how do we calculate that energy? Well, there's a couple different types. One is kinetic energy, and the way that we calculate that is 1/2 times m times v squared. There's another type which is potential energy for gravity. And so just put gravity here. Because there's potential energy in springs too. Oh, that doesn't look good. Let's see if I can fit it in real tiny. Gravity. There we go, that's a little better. And that is it's the mass times the acceleration due to gravity times the height. That's one of the equations. And then let's do an example problem, one more example problem. Do you guys have that written down? So, let's say that I have a car. And it's going with a velocity of 20 meters per second, which is pretty darn fast. And it has, so this is the velocity, and it has a mass of 2,000 kilograms. We'll say 2,500 kilograms. Okay. Well, if I wanted to calculate the kinetic energy of this car, I would just say 1/2 times the mass, which is 2,500, times 20 squared, right? So I'm just taking V and M and plugging it into the equation. So now let's do that on our calculator real quick. So I'm going to say 0.5 times 2,500 times 20 squared. When I hit enter, it's 500,000. So that whole thing, that car traveling at that speed with that mass, has the kinetic energy of 500,000 joules. Okay? So a lot of your homework is just plugging stuff into formulas. Okay? So let's do another example real quick, and I'm going to try to lightning round these examples. Let's say this is Mr. Adams, and I have a bowling ball, and I drop it on my toe. Okay? Well, let's say the bowling ball has a mass of 3 kilograms. Actually, it'd be higher than that, but we'll just... And when it hits the ground at the bottom here, the final velocity is equal to 3 meters per second. What's the kinetic energy? Again, to find the kinetic energy of something, you're just going to multiply 1/2 times the mass times the velocity squared, or 1/2 times the mass, in this case I just put 3, times the velocity, which is 3 squared. So if we plug that in my fancy calculator, that's an awfully big calculator. So I'm going to say 0.5 times 3 times 3 squared. So I get 13.5. 13.5 what? Joules. Okay. So that's basically how you would do that. Let's do one with potential energy. I have a ledge and I have a marble, and the marble falls off the ledge, and let's assume that it falls straight down, right? So but doesn't hit the ledge or anything like that, okay? Well, this distance from here to here is 2 meters. Okay, from here to here is 2 meters. All right. And let's say the marble is 1 kilogram. It's a pretty big marble. So the mass of the marble is, well, let's be realistic. It's probably a 1/2 kilogram. That's still pretty heavy for a marble. It's a steel marble, a lead marble. So anyways, gravity is going to pull it down, so the acceleration due to gravity is 9.8 in the negative direction. But we're not going to worry about the negative sign right now. And it says the brick would, how much energy is in the brick just before it falls? In other words, what is the potential energy of the brick, right? Or I mean, not brick, marble. Okay. So that marble, just before it falls, it has potential energy. Just like in class when I put the car up on the top of the hill there. The car isn't moving until I release it, but when I release it, it goes flying, right? So remember that the potential energy is just the mass of the object times the acceleration due to gravity times the height. Well, we said that the mass of the object is 0.5 kilograms. We said that the height is 2 meters. And gravity, or the acceleration due to gravity, is 9.8. So to find the potential energy of this, I'm just going to say 0.5 times the 9.8 times the height, which is 2. Okay? And then we just plug that in the calculator. So I'm going to say 0.5, oops, make sure I put the right thing in there, 0.5 times 9.8 times 2. Oh yeah, that makes sense. When you take half of 2, it's 1. 1 times 9.8 is just 9.8. So then the potential energy is 9.8 joules. Notice on all these problems, I'm drawing the picture first. I love to draw the picture and then label the information that's given to me in the problem. There's words associated with this problem. I'm skipping the words for you guys. Let's do one more. Example 4. And most of these formulas you should already have written down in your notes. I just wanted to go through at least one example each. There's a spring. Okay. And it has a constant. The spring's constant is 200. Wow, that's a big number. And this is its free length here. So this is the normal length of the spring, right? So we call that the free length. But it's extended 4 meters. It's stretched 4 meters. How much energy does the spring hold? So remember I said there's a potential energy for gravity, but there's also a potential energy for a spring. So you should have this written down. Is that somebody knocking at the door? And that is 1/2, very similar to the kinetic energy, times the constant K times the displacement squared. So this would be X. X is equal to 4 meters. So the potential energy it has, and think about it like this, if I let go of this spring, even though I'm holding it extended or stretched out, it's going to pull back this way. And it's going to pull back with a force. And so a force that's displaced, in other words, it moves something, that's work. Work would be done by the spring. As soon as I release that spring, work is done. If I attach something to that spring, it'll pull whatever's attached to that spring. And I can measure that work. Okay? All right, so what is that potential energy to do work? Well, we just plug it in the formula. The potential energy of the spring is equal to 1/2 times 200 times 4 squared. And so we'll do this one by hand because I like to do math. Bless you. 1/2 of 200 is 100 times 4 squared. 4 times 4 is 16, or 1,600 joules. Okay? Any questions on that?